Hi. To start this discussion off on calculating alignment eyewear, we're going to kind of get on the same page in terms of how the calculations are done, because there's a couple of things we're going to want to take note of so that when we move to the software, um, we'll have a better understanding of how we're going to manipulate the software to help us do the calculation for the OD for alignment eyewear. We're going to start off by looking at the relationship between limiting aperture, irradiance, and optical density. We'll look at a continuous wave laser, and we'll look at the worst case. And to begin with, we'll take a laser beam, which has a total continuous wave power. In laser safety, we always pass the beam through a limiting aperture. We take the power through the limiting aperture and average that power over the limiting aperture. In this case, which is the worst case, the assumption is that all the power from the laser passes through the limiting aperture. So when we talk about laser beam irradiance, we really don't talk specifically about the beam diameter as much as we do averaging the power over the limiting aperture. So in this case, where all the power is passing through the limiting aperture, the laser beam irradiance that we're going to use is the laser power through the limiting aperture divided by the area of the limiting aperture. Now, laser power is in watts, area of the limiting aperture is in square centimeters, so laser beam irradiance or irradiance is in watts per square centimeter. Optical density, or OD, is equal to the log base 10, or the common logarithm, of the laser irradiance, which is in watts per square centimeter, divided by the maximum permissible exposure, or the MPE, which is also expressed in watts per square centimeter. We need the same units because these need to cancel out because OD is simply a value. Now, another way of looking at this is in this equation where we say 10, and this is where we get it, this is the base 10, 10 raised to the OD power equals the irradiance divided by the MPE. We can see that this ratio, this is kind of a nice way of looking at it, because if the irradiance is equal to the MPE, this value is 1. That means in order for this equation to be true, OD would have to be 0. 10 to the 0 equals 1. So when the irradiance is equal to the MPE, the OD value is 0. When the irradiance is 10 times the MPE, this value is 10, OD would need to be 1. So 10 times irradiance, 10 times if the irradiance is 10 times the MPE, OD 1. If the irradiance is 100 times the MPE, it's OD 2, and so on. Okay? Now next we want to look at class 2, because we're always saying when you calculate alignment eyewear, you want to be at class 2. And I'm going to show you why that statement is used, but also how it's built into a calculation. Class 2, the maximum continuous power is 1 milliwatt. We want to remember that. It's 1 milliwatt is the maximum continuous power for class 2, which really means that the class 2 continuous wave power limit for visible light, 400 to 700 nanometers, is 1 milliwatt. Now, how classification is really done is we look at the accessible emission limit, or the AEL. This is the maximum emission level permitted within a particular class. So for class 2, we take the AEL is equal to the MPE for a class 2 laser, and show you how to get that, times the area of the limiting aperture. So this would be the area of a 7 millimeter aperture. Since the MPE is in watts per square centimeter and area is in square centimeters, that leaves us really with watts. So this is a power level we're calculating. And to find class 2, we use the aversion response of 1/4 of a second for our exposure duration, as by the standard. That gives us the MPE for visible light of 2.55 milliwatts per square centimeter. Limiting aperture 7 millimeters, there's the area. When you go through and do the math, The AEL, or the power limit, the average power limit for class 2 is 0.98 milliwatts, and we round that off to 1 milliwatt. We'll come back to this when we're looking at the software, because this is sort of interesting. We talk about the level, the class 2 level being 1 milliwatt, but it's actually 0.98, and it makes a difference when you're looking at the software. So we'll come back and look at that. Want to just mention class 3R. Remember, class 3R is what we call marginally unsafe. Your aversion response may not work, but pretty much these are fairly safe lasers. This is where your laser pointers are classed at, 3R. And the maximum continuous power for 3R is 5 milliwatts. That's 5 times the class 2 limit if we're talking about visible light. And you can look that up in the standard, but the standard calls out 3R to be 5 times the class 2 limit, which means it's for visible light. So that puts the 3R limit at 5 milliwatts. Okay? All right, so after we go through this, we're finished here. We will now take a look at software. Okay, and that'll be in part 2.